Welcome to today's lesson. So in this lesson, we're going to discuss compound angles. By the way, we're still under trigonometry. So these are the three parts that we are remaining with for us to finish trig. So the first part is compound angles, which we're going to do today. And then we also have to do double angle and half angle formulas. Then from there, we'll solve at least 2 questions. We'll solve 2 questions just to make sure that we've understood what we mean by compound angles and double and half angle formulas. And then the next time we're going to meet, that's on Monday, we're just going to discuss graphs of trig equations. And then once we are done with that, then we'll say we're done with trigonometry. The next topic that we're going to start, which is on Wednesday, will be calculus. Then once we're done with calculus, it means that we're done with our syllabus. Yeah, so let's quickly look at what we have tonight. Okay, so double and half angle formulas. So before we look at half angle formulas, first, let me start by talking about double angle formulas. So you have to understand that if they give you, or before we look at double angle formulas, let me first write the compound angle formulas on the screen. Okay, so for sine, we know to say if you've been given the equation sine A plus B, if you have 2 angles adding themselves in brackets, sine A plus B, this one is just given by sine A cos B, then plus sine B cos A. So these, this is called the compound angle formula for sine. And then what happens if you have, or if for instance, A is equal to B? So when A is equal to B, this implies that while there's B here, we're going to replace with A. So this is the same as just having sine A plus A. So while there's B here, we're going to put A, which is just the same as saying sine A plus A. So this will be equal to, when we put, this one will still be sine A. And then even here on cos, instead of having cos B there, we're going to have cos A. And then we say plus sine B, instead of having B there, we have A there. So we're going to put A there as well. Then cos A will still remain as cos A. So now here, the reason why we're calling these formulas double angle formulas, because when you add A and A there, you're getting 2A. So this will be sine 2A. So sine 2A will simply just be equal to, these 2 can add. So when you add these 2, the answer that you're going to get is simply just 2 sine A cos A. So this is called the double angle formula for sine. And then what we have here is called the compound angle formula for sine. Let's look at cos. So for cos, we know to say cos A plus B is simply just given by cos A cos B. So you have to master these. You have to master these formulas. They are very important. So cos A cos B, minus, for cos, if you have a plus here, it means that here you're going to put a minus. For sine, if there's a plus here, it means that there's also going to be a plus. If there is a minus there, it means that even there, you're going to have a minus. But for cos, it's always the opposite. For cos, if you have a plus there, here in between here, you're going to have a minus. So this will be sine A sine B. So now, even for cos, we're going to do the same. What happens if we say A is equal to B? So meaning while there's B here, we'll put A. So this will be cos A plus A. So cos A plus A, this is just going to be cos A. Then while there's B there, we'll put cos A as well. then we say minus, we have sine A, then while there's B there, we're going to have sine A as well. So A plus A there, we'll have cos, A plus A, this will give us 2A. So this is also known as the double angle formula for cos. So cos A times cos A, you're getting cos squared A. And then we say minus sine A times sine A, the answer will be sine squared A. So this one is called the double angle formula for sine, for cos rather. So here, this equation can be changed. We can manipulate this into, I think, about 3 more equations, this one. And by the way, this is not a Pythagorean identity. Pythagorean identity has a plus in between, but this one has a minus. That's the difference. For Pythagorean identity, remember we said it's always sine A, sine squared A, plus, cos, sorry, sine squared A plus cos squared A is equal to 1. This is called the Pythagorean identity. Yeah, so this one can be changed into several equations. Okay, let's move on. So this is what I was talking about. Sine A plus B is given by that. So for sine A minus B, you just have to change the sign there. That's all. And everything remains the same. So when we say let A be equal to B, this is what I was explaining. You're going to have sine A cos A plus cos A sine A. And then sine 2A becomes 2 sine A cos A. So this one is called the double angle formula for sine. So what if we divide the angle? The angle here, if we divide it by 2, what happens? If we divide this by 2, means that all the angles this side will also be divided by 2. So when you divide the angles by 2, we're going to have this expression here. So this expression that you've seen here, or let me show you the simplified version of it. So this side, when you divide sine, 2A by 2 will remain with A. So this is going to be sine A is equal to 2 sine A over 2 cos A over 2. So this one is called the sine angle, rather it's called the half angle formula for sine. So this one is the half angle formula for sine. Okay. So I've tackled two subtopics, 2 minor topics on one page. Okay. So this one is called the half angle formula for sine. Let's look at cos. So for cos A plus B, I said that sine, if you have a plus there, for cos there's always a minus. So if you have a minus there, cos will have a plus there. So
you are fast, sir.
I'm very fast. Okay.
Yes.
Okay, so I was saying for cos A plus B, you say cos A times cos B. If you have a plus here, it means that for cos, you always have a minus, the opposite sign there. So for sine, if you had a plus here, if you have a plus here, for sine, you always have a plus also there. But since we're dealing with cos, the sign will always be different. So you have a plus there. Here you're going to have a minus. That is for cos. So now what happens if we also introduce, okay, so I explained all this. If you also say let A be equal to B, it means that you're going to have A plus A. If we say A is equal to B, so meaning while there is B there, you replace with A. Even this side, while there is B, you're going to put A. So this will be cos A plus A. This will give us cos squared A minus sine squared A. So this is called the double angle formula for cos. So for the half angle formula for cos, you simply just divide the angles by 2. So when you divide the angles by 2, you get what is known as the half angle formula for sine. Okay, before we look at the half angle formula for sine, let us see the other ways you can write this double angle formula for cos. Now imagine that, okay, remember I said the Pythagorean identity is given by sine squared A plus cos squared A is equal to 1. So now what happens if we make one of these the subject of the formula? Let's say we make sine theta the subject, I mean sine squared the subject. If we make sine squared a the subject, meaning we're taking cos squared a to the other side of the equal sign, this side. So we're going to have sine squared a is equal to 1 minus cos squared a. So I'm going to replace this sine squared a with 1 minus cos squared a. So I'm going to have cos squared a minus, I'll put in brackets since I'm replacing, minus 1 minus cos squared a. So this is going to be cos squared a. This minus times 1 to be a minus 1, minus times negative cos to be a plus cos squared a. So when I add this cos squared a and this cos squared a, the answer will be 2 cos squared a, and then I'll write my minus 1 there. So this one is also the double angle formula for cos. So this is why I said you can manipulate this expression into 3 more different ways. So the same thing I've done here. Let us now make cos theta, I mean cos a the subject of the formula. So if we make cos a the subject of the formula, we're going to have cos squared a being equal to 1 minus sine squared a. So cos squared a will be equal to 1 minus sine squared a. And this means that we're going to replace what is cos squared a, which is this part in this expression. I'm going to put 1 minus sine squared a. Okay. So this is what I was just explaining. So while there's cos squared a here, I'll put 1 minus sine squared a. And this is what I'm going to have. So when I have this, if I open the brackets, I'm going to have this as a simplified version. So I'm going to have 1 minus this and that will add to get negative 2 sine squared a. Okay, so there's also another one, which is this one. This one I've already explained it. So this one is also called the double angle formula for cos. Even this one, it's a double angle formula for cos, even this one. So these are not only used to solve identities, but they are also used to solve trigonometric equations. Okay, so if you divide the angles by 2, then you make what is known as the half angle formulas for these same expressions. So if you divide all these angles by 2, you divide the angles by 2, you're getting these 2 expressions as your half angle formulas for cos. Okay, so let's look at tan. So these are the formulas, the double angle, I mean, these are the compound angle formulas for tan. In case you can't see, tan A plus B, this one is just given by tan A plus tan B, then everything over 1 minus tan A, tan B. So even this one can do what we did when you put A there. When you say let A be equal to B, when you put A there, it means that you're going to have something like this. While there is tan B there, you're going to be putting A. So you just have tan A plus tan A, then everything divided by 1 minus tan A, tan A. Meaning when you simplify this, on top tan A plus tan A, you're getting 2 tan A. And then down there, we're going to have 1 minus tan A times tan A. This will be tan squared A. So this is the expression for the double angle formula for tan. So this one is simply just tan 2A. This is 2. So tan 2A is given by this. Okay. So
excuse me, sir.
Okay. You have a question?
Yes, just bring back the formula for tan A there. That's where.
It's this one.
Okay. There, when we say tan, when we replace where there is a b, we put a, we are having 1 plus tan A. And when we multiply tan A times tan A, isn't that squared supposed to include A also?
No. To be tan squared A. So tan squared A is simply just the same as tan A times tan A. So if you want, you can't write it. You can't write it as tan squared A. You can write it as tan A squared. It's still the same. So this is just the angle. Then tan is the trig ratio. So you put the squared here, not on A. Okay. So this is called the double angle formula for tan. Then the half angle formula for tan is you simply just divide the angles by 2. You divide the angles by 2. Whatever that you get there is called the half angle formula for tan. Okay. So I think this slide is important. I'll not only send the recording, I'll also send the slide. Okay, so this is for cos. Yeah, so I think I talked about cos. Okay, I think I talked about cos. So it's just some question. Okay, so let's look at trigonometric identities. I'm just going to point out the identities which are very important that you are going to be using. So the first one is the Pythagorean identity. So Pythagorean identity is also one of the trig identities which is very important. If you can't know it, at least master it. And it's not difficult. This is just sine squared A plus cos squared A is equal to 1. That's all. It's just this part here. This is called the Pythagorean identity. So what happens if we divide the Pythagorean identity by sine theta? So when you divide sine theta plus, over sine theta, the answer will be 1. Then we say plus, when you divide cos squared A over sine squared A, remember what I said, cos over sine, cos A over sine A, cot A. So if we have my squared there, it means that we're also going to put a squared there. So this part will give us a 1. Then we say plus this part here, this one is cot squared A. Then 1 over sine, remember what I said? 1 over sine is simply just cosec squared A. I said 1 over cos A is equal to sec A. Then 1 over sine A is equal to cosec A. Then 1 over tan A is equal to cot A. So this is also important. Then cot A can also be written as, cot A can also be written as, because we know that tan A is simply just, we know that tan A is simply just sine A over cos A. We know that tan A is equal to sine A over cos A. So we can say 1 over, where there's tan A here, we can put this part, which is sine A over cos A. So put sine A over cos A here. So the reciprocal of this is also cot. So the reciprocal of sine A over cos A is also cot. So meaning this will be cos A, cos A over sine A. So cot A can also be written as cos A over sine A. So if there's a squared, it means that you also have to include the squared there. So this is what I was just trying to explain. Then you should also understand that cosec A can also be abbreviated as cosec A. Just write CSC. So cosec. So what if we divide by cos? We divide the Pythagorean identity by cos. So if we divide this by cos, remember what I said, sine A over cos A, the answer is tan A. And then we say plus cos A over cos A, the answer is 1. So this is equal to 1 over cos A. Remember I said it's sec A. So if you want to master these, you don't want to be forgetting, since they all have squared, you also have to put squares. So if you don't want to forget the sec, the tan, the cot, the cosec, simply just have to do this. Sec, if I write sec, okay. So if I write sec A, just count 1, 2, the third letter represents what is going to be the denominator. So 1, 2, 3. So in this case, the third letter is C. So meaning I'm going to have cos A. I say cos sec A. The third letter is 1, 2, 3. So this one is 1 over sine A. And then if I say cot A, the third letter is 1, 2, 3. The third letter is T. So this will be 1 over tan A. This is how you master it. Okay. So we look at other trig identities. Cot A, I said it's cos A over sine A. Yeah, so we also have the double angle formula for cos, which I explained. We also have the half angle formula for cos, which I also explained. Then there's also the half angle formula for cos. This one is supposed to, so they have angle formula for cos. Okay. Then we also have a double angle formula for sine, which I explained in the previous slide. Then there's also a half angle formula for sine, which I also talked about. We also have the double angle formula for tan and the half angle formula for tan, which I also explained. Okay. All right, so let's look at this question. This is a question, the first one here, but this is a question from your assignment. This one says cos x. So it's cos x cos 30 minus sine x sine 30 is equal to 1 over 2. So if you remember the double angle formula, or the compound angle formula for cos, let me just go back to it. Compound angle formula for cos, I want to show you. Okay, this one here. Okay, forget about this. I just want you to focus on this. So cos A plus B is equal to cos A, cos B minus sine A, sine B. So let's jump to that slide. Okay. So cos x cos 30, if we take x as A and 30 as B, this is just the same as having cos x and cos 30 minus sine x sine 30. This is the compound angle formula for cos, which can also be written as cos x plus 30. Cos x plus 30. Okay, let me just go to that same page. Avoid disturbances. Let me do this. Okay. So I was saying, So this is just the same as saying cos x plus 30. I hope you're able to see the screen. So cos x plus 30 can also be written as cos x cos 30 minus sin x sin 30. So I've just reduced it to that. Then we say this is equal to half. So now we can find the reference angle. How do we find the reference angle? Let us first equate this to phi. So I'm going to say let x plus 30 be equal to phi. So that we have cos phi is equal to half, this half here. So to find the angle, which is phi here, the reference angle, we're going to say phi is equal to the cos inverse of half, cos inverse of half. So cos inverse of half is simply just 60 degrees. So cos inverse of half is 60 degrees. So now we look at half. Is half negative or positive? If it's positive, then we take the quadrants where cos is positive. So the quadrants we have are these. We know that in the first quadrant, all trig ratios are positive. In the second quadrant, only sine. In the third quadrant, only tan. In the fourth quadrant, only cos is positive. So in the first quadrant there, we know that cos is positive. Hence, we know to say our reference angle, this one is our reference angle. So our reference angle lies in, so we can say phi lies in the, so phi lies in the in two quadrants. The first one, because we know that it's positive, half is positive, meaning it's also in the first one. So phi lies in the first, and the other quadrant where 60 is positive, I mean the other quadrant where cos is positive is the fourth quadrant. So meaning phi lies in the first and fourth quadrant. So now in the first quadrant, so in the first quadrant, you find the reference angle is the answer that you get. I mean, it's the angle that you get as your answer. So in this case, the reference angle is 60. So in the first quadrant, they asked us to find x. So in the first quadrant, phi will still be what? 60 degrees. But the question is not asking us to find phi, but x. So we recall that x plus 30 is equal to phi. So we say x plus 30 is equal to phi. So what is phi? I'm going to put 60. So we say x plus 30 is equal to 60. So we take this 30 to the other side of the equal sign, meaning we have x is equal to 60 minus 30, and the value of x becomes 30 degrees. So the first value of x that that they wanted us to find is simply just 30 degrees. Then the other value of x, we get the phi, which is in the fourth quadrant. So we know that in the fourth quadrant, we find the angle by saying 360 minus the phi that you have found. So we say in the fourth quadrant, so in the fourth quadrant, phi is equal to 360 degrees minus the reference angle that we have is 60. So minus 60, meaning phi is going to be equal to 300 degrees. So we have not been asked to find phi. We are finding x. So how do we find x? We know that x plus 30 is equal to x plus 30 is equal to phi. So while there is phi, I'm going to put 300. So I'm going to say x plus 30 is equal to 300 degrees. So to find the x, I'm going to take 30 to the other side of the equal sign, meaning I'm going to remain with x this side, and it will be x is equal to 300 degrees minus 30. So the value of x becomes 270 degrees. So the values of x that they wanted us to find are x is equal to 30 and x is equal to 270. But if they have given the domain to say maybe x is ranging from negative 180 to from negative 180 to 180, it means that 270 will be disqualified because it's not in this range. I mean, it's not in the domain that has been given. So I mean, the answer that we get is only 30. But if there's no domain that has been given, or if the domain was given that x is ranging from 0 to 360 degrees, means that the value of x will have is, x is equal to 30 and 270, because 30 and 270 are between 0 and 360. Okay, so let's quickly do the last one. She's saying so.
How is up?
Okay, don't worry, I'm going to send the recording, and I'll also send. The problem with you people is that when I send a link in the group, that make sure that you go through this. You don't go through them. You're just waiting for us to have a class. The reason why sometimes I send those is because I know to say if you watch that, and then on top of that, you come and put, you come and add the knowledge that I'll teach you during a live session. At least it will be easier for you to understand. So make sure when I send a link, so immediately after this, I'll send this. I'll also send the link. I'll also send the link where I explain certain things like this, because there are certain words that I may not use today, but maybe I use them in a certain video, which made that video to even be easier to be understood. Okay, I'm going to send the recording. There are also other practical questions that I'm going to send, which you answer as an exercise. It's been long since I gave you an exercise. Okay.
So before you leave,
Okay.
I've got a lot of questions now. Just a quick one.
Okay, you can ask.
There, on the first quadrant.
Okay.
Yeah, you say the phi lies in the first quadrant there.
Okay.
I understand. It's there all the quadrants are. Yes. Now that's 60, the first quadrant. Why is it lying in because the angles it's 27360? And there the phi is 60. Why is it lying in the?
And what's your question again? At why is it lying where?
In the cos there. This the phi is 60. Why is it in the cos?
Okay. So it's in the cos because you are not following the 60 degrees, but you are following. That's why I was emphasizing to say if half is positive or if half is negative.
Yesterday.
Yes. So meaning if half is positive or negative, that is what will determine whether your ratio here lies in the first, second, third, and fourth. Because you know that cos is only positive where cos is. Sine is only positive in the second quadrant and in the first quadrant. Tan is only positive in the third quadrant and the first quadrant. And then cos is only positive in the fourth and the first quadrant. And the positive part we are saying positive is the positive of what you have inside. So if we had -2, the quadrants here would have been the second quadrant and the third quadrant, because we know that this half here is having a negative. If we had -2 this side, would have said, phi lies in the second and third. Why? Because we know to say cos is only negative in the second and the third quadrant. It's positive in the first and the fourth quadrant. Have you gotten the point?
So where is lying? Phi 60 degrees.
No, don't say where is 60 degrees. No, you should say where is cos negative. Follow cos and the negative sign. Don't follow the reference angle. This one, that's the reason why we're calling it the reference angle. You just refer to it. That's so. You just use it to find answers. But what determines the quadrant is the negative or the positive of what is this side and the trig ratio itself. So what I mean is that I chose to say phi is in the first and fourth quadrant because this side was positive half. And I know that I was dealing with cos. So cos is only positive in the first quadrant where all the trig ratios are positive, and in the fourth quadrant where only cos is positive. Have you gotten the point?
Yeah.
At least, huh? So if
At
we
least.
yes, so if we had a minus this side, if for instance, this was negative half. So if this was negative half, we would have said cos is negative where? In the second quadrant and the third quadrant. So would have said phi lies in the second and the third quadrant. That's how it is. So you follow the sign, which is this side. You also look at the trig ratio that you've been given. So the link will end very soon. You just have to rejoin the class using the same link so that we discuss the last part of this question.